So we have another AIME problem. So this is a number 3. So the question says find the only real number that can be expressed in this form where the I squared is -1, which is our just imaginary number, and b are positive integers. So this is the another key information. So like, the third power of a binomial is not too big deal. So let's expand a plus b to the third power by using the cube of a binomial. So that should be, or just binomial theorem. So that should be equal to a cube plus 3 times a squared. So that should be a squared times b, which is bi. And then plus 3 times a to the first power times bi to the second power plus bi to the third power. And then there is a minus 107i. So just to remind, like we know if we have a binomial to the third power, we can use the binomial theorem, or just the third power of binomial is something we should remember. So this is a cube plus 3a squared plus b plus 3ab squared and plus b cubed. So this is what I just used now. And you may use the Pascal triangle for this coefficient. And now if we simplify this guy, so it will give us a cube. And then this is going to be 3a squared bi. And then since we have b and I to the second power, that will be b squared times I squared. I squared is -1. So that will be -1 times b squared. When you multiply with those, that should give us -3a b squared. And then there is no imaginary number anymore. So, and then the third power of I is just I squared times I. That will be -1 times I, just -1. And that would be -b to the third times I, and then minus 107i, basically. So what we are told, this is there is a real number that can be written in this form. If there's a real number, then there is no imaginary part, which means the coefficient of the I, when you write as a complex number, should be 0. So let's go ahead and do that. So that will give us a cube, that's the real part, and then minus 3ab squared, and then that's also real part, and then the remaining part should be, if I pull the I as a factor, so that should give me 3a squared b from this term, and then this guy will be minus b cubed minus 107. So then if this is a real number, because we are told there is only one real number, can be expressed in this form. So then the coefficient of the I should be 0. So let's go ahead and deal with that. So 3a squared b minus b to the third and minus 107. So this has to be 0. Since we are told the integer a and b, so which is why it's easier to deal with if we can factor or write the expression is equal to some number divided by expression. So like I see the b is common on the left side. So if I pull the b on the left, so you will get 3a minus b squared is equal to 107. Since 107 is a prime number, maybe we can just find the factors of 107, which could be 1 and 107 or 107 and 1. We don't want to deal with the negative version since we are looking for a and b to be a positive integer. If I go with b is 1, if b is 1, right, and then this guy would be 3a minus 1. Actually, this was 3a squared. And equals 107. So if you add 1, that's 108 divided by 3, 36. A squared is 36. So the a has to be 6 or -6, but we cannot choose the negative version because that we are told they are positive. So 6, 1 does work. So the a, b is just the 6 and -1, right? I mean 6 and +1. So then if I try the 107 for b, then there is no integer value of a, so which is why that's the only one, and then we are told this is the case anyway. And what we want was the real number itself. So if we are looking for the real part, which is this part, because this guy will be 0, then our final answer, if you plug it there, so you will get 6 to the cube, minus 3 times 6 times 1 square, and this will be 198. So I hope that was clear. So this was a number 3 on the AIME. So that's just the straightforward algebraic manipulation. I'll see you next time.